Hello! Today we're going to experiment with a new mech joint. We'll just zoom right in here to see what I've cooked up. I've slapped an extra metal cage onto the mech's torso for a more stable shoulder joint mount. And I've got a compound joint by bolting two winch drums together. I did have to do a bit of metal reinforcement to the PVC frame to keep it from getting too wiggly. And I think this is a rather elegant looking solution myself. To do some basic manual control, I just have some standard winch controllers attached to each winch. These are connected through a long string of spaghetti to a pulse width modulation controller I got off Amazon. I can control the speed using this knob here. Now, one advantage of using these winch motors is that you can unlock them by pulling on this knob right here. So when the mech is deactivated, the arms can be repositioned for transport. I can easily move it by hand, and you can see the range of motion we get out of it. Now I'll just set it back down. Now for this manually controlled test, I'm just pressing the buttons on the winch controllers. You can see it moves around quite a bit, not only because there's only one speed and we get a lot of wiggle, but because there's no motor deceleration, so it just suddenly starts and stops. Ideally, we'll have a computer attached to this knob. And then try adding some more support to this arm frame. So now here we got a really big fish hanging up. There's only one point of contact really between the metal and the PVC frames. So off camera we'll just be adding some more points of contact from keeping it from moving around so much. Now here's a shoulder joint without the arm. Now there is a bit of give in the gearboxes unfortunately, and that's something we'll just have to deal with. With our computer controlled circuits, we'll be having a 50 amp fuse to keep anything from catching on fire, a power switch for the entire system, a power bus to easily distribute electricity to the various components, one motor controller for each winch to control the speed via pulse width modulation, computer controlled servos attached to the motor speed knobs to, well, control the motor speed. We've got relays to change the polarity of the throttled power to the motors. These are controlled with servo switches. Servos that trigger switches to make the relay switch between forward, reverse, and off. And then all that goes to the winch motor right here. When we manually move the servo throttle, it increases the power the motor controller puts out. We'll set it to about 67%. And now when we manually move the servo switch, it changes the polarity of the motor, making the motor rotate backwards and forwards. And we can hear a difference when it's on 100% speed. Now we have the board installed and all wired up to the mech's computer and coded. It's a little twitchy, but you can see the servo throttle slowly increasing as we move the thumbstick. And the servo switches triggering depending on which direction we move the thumbstick. We can also do compound movements. So let's see how it can control the winch alone. So there isn't actually much difference in the winch's speed. That is because this relay requires about 7 of 12 volts to actually trigger, and the current to trigger the relay comes out of the pulse width modulation controller. So anything under 59% doesn't actually make it to the motor, so we don't actually get a lot of speed difference. We'll be upgrading this to an all-in-one solution, one that has the polarity changing built right on in. So we'll just confiscate this old control board and bring it inside. So now we'll remove these old motor controllers and these old winch control relays. And we'll only reposition these servo switches since we're all about repurposing as many old parts as possible. Now we'll add the new all-in-one motor controllers and secure them in place. Gotta do the old grabby check to make sure they won't go anywhere. So now we have our power buses just connected to the motor controllers, where the throttling and polarity switching magic happens. Our servo switches have replaced the old original switches on the new motor controllers, and the servo throttles are thankfully the same. So now we have a tidier package. Let's see how well it works. We'll just slap the new board in here. And now with everything rewired and recoded, let's try it out. The motor moves forward nice and slow. And then back nice and slow. And we can even change speed on the fly. You can see all the servos moving back there on the board, making it a rather visually interesting piece. So now that we've got it all tested, it's time to reattach the arm. Now once the arm itself is positioned, attaching it is actually pretty easy. You just slap this winch motor on here and bolt it on. Now let's check out that arm movement. Alrighty, we got some lower speeds, so we'll just take it nice and slow. Oh, gravity is helping bringing the arm down faster, so we'll have to compensate for that in code later. We'll try bringing the arm up and swinging a little faster this time. There we go. Now let's check out the arm lowering throttle again. Nope, still too fast. But in the meantime, let's reconnect the elbow motor. There we go. Now let's check out the full range of motion the arm has. Boom! She hit her own head. Let's try it again. There we go. Stop before hitting it. Whammo! If she can hit her own head, she'll be able to hit an enemy robot's head. But before I do any more damage, I'll stop the video here. Remember to like and subscribe. And remember, if the women don't find you handsome, they should at least find you handy. Take care.